The partition pruning engine is a cost-based query optimization layer responsible for eliminating unnecessary partition scans during query execution. The engine operates by analyzing query predicates against stored partition metadata to determine which table partitions contain relevant data. This process occurs during the logical optimization phase, after query parsing and before physical plan generation. Partition elimination reduces I/O overhead and improves query latency by narrowing the search space to qualifying partitions only. Partition metadata is maintained in a system catalog table named sysPartitionBounds. This table stores the minimum and maximum values for each partitioning column across all partitions of a given table. Metadata entries include partition identifier, column name, data type, min value, max value, row count estimate, and last update timestamp. The engine queries this catalog synchronously during optimization. Stale metadata degrades pruning effectiveness, so metadata refresh must occur after bulk data modifications. Predicate analysis begins by decomposing the where clause into atomic comparison expressions. The engine normalizes predicates to canonical forms, converting inequality chains and between clauses into equivalent ranges. Complex predicates involving and operators are evaluated as intersection of partition sets, while OR operators produce union. The engine maintains a predicate tree structure where each node represents either a filtering condition or a set operation. Predicate pushdown applies these filters bottom-up through the tree. Range intersection algorithms determine partition eligibility through closed interval arithmetic. For each predicate, the engine constructs a required range and intersects it with each partition's known bounds. A partition is eliminated when its bounds do not overlap the required range. The intersection computation accounts for data type semantics, including null handling and type coercion rules. Numeric, temporal, and string domains use distinct comparison operators defined in the type system module. Multi-column partitioning schemes require composite predicate evaluation. When tables are partitioned on multiple columns, the engine applies pruning independently to each column, then combines results. Columns partitioned in hierarchy order benefit from early elimination. For example, a table partitioned by year then quarter first eliminates non-matching years, then evaluates quarters only on remaining partitions. The order of column elimination affects the computational cost of the pruning phase, though final result accuracy is unaffected. Metadata refresh is triggered implicitly by certain operations and explicitly by administrator command. Insert, update, and delete operations that span entire partitions increment a modification counter on affected partitions. When this counter exceeds a configurable threshold, or at a scheduled interval, the metadata refresh process scans partition statistics. The refresh operation locks the relevant partitions at share level, preventing concurrent writes during scan. For large tables, refresh operations are typically scheduled during low traffic periods. The statistics computation phase evaluates actual data bounds by sampling or full scanning. Sampling mode reads every nth row from each partition to derive statistical estimates. Full scan mode examines all rows to compute exact bounds but requires higher I/O cost. Sampling frequency is configurable via the parameter partition stats sample rate, with default value of 10%. The engine logs sampling parameters and estimated accuracy in the system event log for audit purposes. Histogram construction creates density distributions for numeric partitioning columns. The engine divides the value range into contiguous buckets and records the count of distinct values in each bucket. Histograms enable more precise cardinality estimation for range predicates. The histogram resolution parameter controls the number of buckets, with recommended values between 50 and 500 depending on data skew. High skew columns benefit from increased bucket counts to capture distribution variations accurately. Join predicates between partition tables require cross-partition analysis. When joining two partition tables on their partitioning columns, the engine evaluates whether partitions from different tables can produce matching rows. Equijoin conditions on aligned partitioning columns enable partition-wise joins, where only matching partition pairs are scanned. Misaligned partitions are excluded entirely from the join plan. This optimization is particularly effective for large analytical queries over denormalized fact tables. Pruning decisions are cached in the query plan to avoid re-evaluation on repeated execution. The cache stores the set of eliminated partitions keyed by query signature and parameter values. Parameter binding mode enables cache reuse across queries with identical structure, but different literal values. Cache validity depends on metadata freshness. When metadata refresh occurs, the pruning cache is invalidated and subsequent queries trigger reevaluation. Cache statistics are available through the system view sys pruning cache. Partition constraint information is derived from partition definitions and stored redundantly in metadata. Constraints defined at partition creation time are immutable and therefore precise. Dynamic constraints inferred from data statistics are heuristic-based. The engine distinguishes between definitive constraints that guarantee partition elimination and probabilistic constraints that suggest elimination. Definitive constraints are always applied. Probabilistic constraints are applied only when statistics confidence exceeds a configurable threshold, defaulting to 80%. Temporal partitions require special handling for queries on date and timestamp columns. The engine recognizes standard temporal partition naming patterns, such as yim and yimd, and interprets them automatically. Temporal range queries are converted to partition list membership efficiently. Queries spanning multiple calendar periods expand to cover the exact range of partitions required. This enables efficient queries like finding records from the last 90 days without explicit partition enumeration. The partition elimination plan is included in the explain output as a separate optimization section. The output lists predicates analyzed, partitions eliminated, remaining partitions, and estimated row reduction percentage. This information aids in diagnosing pruning effectiveness for slow queries. The explain plan statement accepts a pruning option that produces detailed elimination logic. Developers use this output to verify that partition structures support intended query patterns and identify schemas requiring redesign. Subquery pruning extends the engine to nested select statements. Predicates from outer queries are pushed down into subqueries, enabling partition elimination in the inner scope. The engine verifies predicate validity before pushdown, ensuring that aggregation functions and group by clauses do not invalidate pushed predicates. Correlated subqueries require careful handling to preserve semantic equivalence. The rewrite optimization pass includes subquery decoration with pruning hints from the outer context. Partition expansion recovery handles cases where no partitions satisfy pruning constraints. The query optimizer detects this condition and returns an empty result, set immediately without plan execution. This early termination prevents unnecessary resource consumption. Alternatively, if the query optimizer suspects pruning errors due to stale statistics, it may revert to table scan plans. The configuration parameter partition prune safety mode controls this behavior, with conservative mode erring toward full scans. Performance monitoring for partition pruning is available through the system view sysquery partition stats. This view records partition access counts, estimated rows eliminated, actual rows read, and pruning latency for each query execution. Long-running queries benefit from periodic analysis of these metrics to identify opportunities for schema optimization. Tables with low pruning ratios indicate possible misalignment between query patterns and partition schemes, warranting design review. The monitoring module operates with negligible overhead and runs continuously.